Okay, so here is the second part, the midterm review angles, which is pages 3 and 4. So when you have vertical angles like that, I think we recognize those pretty quickly now because they popped up in constructions and proofs and then by themselves in the angles unit. But we have congruent vertical angles, and if they're congruent to each other, then you set them equal to each other. That's what that means. They're equal to each other. So solve it algebraically, and you will have negative 4x equals negative 84. So we're essentially dividing 84 by 4, which gives us that x equals 21. Did they want us to plug it in? No, they just wanted the value of x, so we're good to go. In number 2, these two angles, zoom in a little bit, are they the same size or different sizes? That's a very big obtuse angle, and that's a tiny little acute angle. So they are not the same size as each other. They are a linear pair. They are supplementary, also known as they add up to 180. So in this particular case, we combine like terms. 4x's and 60 equals 180. Subtract 60 from both sides. Divide by 4, and x equals 30. Is that all they wanted? Yes, just find x. But be careful, sometimes they say plug in to find a certain angle, and sometimes they let you stop at x. In number 3, they didn't label it for us. This time we had to label angle A on our own, and label angle B on our own. And if you look closely at them, they're either going to be the same size or different sizes when you have parallel lines with the transversal. This is slightly bigger than 90, so that's obtuse. This is slightly less than 90, so that's acute. They are not the same size as each other, which means they're supplementary. They add up to 180. So just like the last problem, we will add up our like terms. 5x's and 25 equals 180. Subtract 25 from both sides. You have 155. Divide that by 5. Reminding you that you need a calculator for the region or for the midterm. And x will be 31. Again, they said find the value of x, so we can stop there. But always look to see if they said find angle A, in case you would have to plug in your 31 to one of the expressions. But in this case, they did just say find the value of x. Number 4, we have alternate interior angles, and you may know those are congruent by definition, or look at the picture and you have two acute angles, which means that they have to be equal to each other. So I started by subtracting 4x from both sides. Then I will add 9. I have 39 equals 3x. Divide both sides by 3. And x is 13. And once again, just find the value of x. And I've done that. Number 5. First you have to label CEW and BEX. And I really think we need to be sure we understand when angles are labeled as 3 letters, CEW and BEX, I still find that not everybody knows what that means. C to E to W. That's the path the angle takes. The middle letter is probably the most important because that's where the vertex is. But it's saying it starts at C, turns at E, and heads toward W. And this one starts at B, turns at E, and heads toward X. So that's the first part. We have to know where the two 50s go. They're both 50. And it wants us to know, or it wants us to find out what EGF is. E to G to F. It's this angle down here. So since the lines are parallel, WX and YZ, then I have corresponding angles here and here. And I have corresponding angles here and here. So EGF is going to be 50 degrees because of corresponding angles from parallel lines. Number 6. In this case, they wrote some information in words, but then they also labeled it on the picture. Sometimes it's just up here and not down here, but in this case they labeled it in both places. The lines are parallel, which means I have parallel lines, transversals, and all your alternate interior and vertical and corresponding all holds true. Before we even get to anything to do with parallelism, just start filling out everything that you know. If this angle is 130, these are on a line right here, so that one must be 50 because they have to add up to 180 next to each other. Now you see this triangle in here. Triangles add up to 180 as well. And right now I have 90 and 50, which is 140, which means the other angle has to be 40. This entire corner down here is 65 because we have 40 and 25 together. So that's 65, which means it's alternate interior with that 65 there. So x is 65. There were probably 3 or 4 different ways that students showed me how they did it the other day in class. So there are more, multiple ways to do this. That's just one. But it's like a puzzle. I started here and just worked my way around until I had enough information. And you could have started somewhere else as well. Number 7, we get into a few questions here that have to do with the exterior angle theorem. We know that 3 angles inside a triangle add up to 180. But what else we learned earlier in the year was 2 angles inside of a triangle add up to the opposite exterior angle. So you can use a shortcut here. 60 plus 50 is 110. That's exactly what that angle is on the outside. The long way to do that would be 60 and 50 is 110. 180 minus 110 is 70. And then these two have to be 180, which puts that back to 110. So you can do it, you can work your way inside and then find the supplement outside, or you can just know the exterior angle theorem, that 2 angles inside automatically add up to the angle that's furthest away on the outside. The reason that's important is on the next problem, it's variables. This would be a little bit trickier because they're not just numbers to add or subtract. So here, I would use that same rule. The 2 angles on the inside add up to exactly the opposite exterior angle on the outside. And then you would subtract 2x from both sides and you'd have x equals 40 and you're done. The long way to do that, you would have to say, what is that angle? You'd have to take 180 away from 3x because I don't know what 3x is, but I know 180 minus that is its supplement. And then you could add these 3 up to add up to 180. Definitely the longer way to do it when you have variables. So if you just understand that 2 angles on the inside automatically add up to the opposite exterior, it will be far easier. Here we have a number 9, isosceles, an isosceles triangle. And it tells us that AB, right here, is equal to AC. And it tells us that angle A is the vertex angle at the top, and that's 80 degrees, which means that this and this are the base angles which have to be congruent. So 180 is an entire triangle. You take away the 80 that we have at the top, we split that in half, and these two both have to be 50. It wants us to find ACD, which is this exterior angle over here. It has to be 130 to add up to 180. And number 10, no picture, so you have to draw it yourself. Isosceles triangle RST. An isosceles triangle just has 2 sides that are the same. It says R is the vertex angle, so R has to be up there. And S and T really don't matter. Angle S is 77. Well, that means T has to be 77. 77 and 77 add up to 154. The only angle left would be 26. There's angle R. In number 11, the mid-segment theorem was something we talked about in the angle unit. It has to do with midpoints. If you know something is a midpoint in a triangle, such as if E was a midpoint and if F was a midpoint, that means that the mid segment is exactly half of that side. The question is, how do we know that E is the midpoint and that F is the midpoint? Well, if this is 8 and this is 16, then that has to be the midpoint numerically, because both of those would be 8. So that proves that E is the midpoint. A few of you asked, well, then how do we know F is a midpoint? That comes from the fact that there's also two 90-degree angles given. So if those lines, that proves that those lines are parallel. Once that's parallel, F has to be the midpoint, which means that EF is 6, half of 12. The one thing to remember there is the mid-segment theorem was if you know that E is a midpoint and F is a midpoint, remember that that segment is always half of that segment, which shows up again here. AB is 6, BC is 8, AC is 12, and then here it tells us X, Y, and Z are all midpoints, so it flat out tells us that. If that's a midpoint, and that's a midpoint, and that's a midpoint, then if this is 12, then that's half of that, because it's parallel to it. If that's 6, this would be 3. It's not asking us that. If this is 8, then that is half of that, which is 4. It wants us to know the perimeter of XYCZ. XYCZ is this parallelogram right here. Opposite sides of a parallelogram are equal, so we have 6 plus 4 plus 6 plus 4, which is 20. Number 13, what's the perimeter of triangle ABC? So here they give us the little ones on the inside and ask us to find the perimeter of the big triangle on the outside. If this is 18, then that is 36. If this is 9, then that is 18. If this is 13, then that is 26. Then you add up 36, 18, and 26, and you'll have the perimeter of ABC. 36, 18, and 26 is 80. So between those two videos, I've just walked you through pages 1 and 2 of the constructions, pages 3 and 4 of the angle measures. And if you go through that today or tonight, the next video I'll post probably tomorrow will be the rigid motion section at least, and we'll do a little bit each day, and we'll walk in and be ready on Thursday.